Okay, so what if I told you there's a way to, like, sprinkle some special rock dust on a field, and it could pull huge amounts of CO2 right out of the air?
And not just that, but it also helps farmers get better crops.
Exactly. Sounds almost too good to be true. But that's basically what just won Matty Carbon, an Indian-led group, the massive $50 million XPRIZE for carbon removal.
Yeah, it's a huge deal, and we're going to dive into how they're doing it.
Because it's not some sci-fi tech.
No, not at all. They're basically speeding up a natural process. It's called enhanced rock weathering, or ERW. They use basalt, just common volcanic rock, but ground up really fine.
So the farmland itself becomes a kind of carbon capturing machine.
Pretty much. And it fertilizes the soil at the same time. It's this double benefit that's so interesting.
That's what really grabbed us too. We wanted to understand, the nuts and bolts of it, how it actually works on the ground for farmers, and frankly, the challenges of making this a big thing.
Right. And we've got some great insights from an interview in the Indian Express with Mati's founder, Shantanu Agarwal, and their chief science officer, Jake Jordan.
Okay, let's get right to it then. How does just spreading rock dust actually grab CO2?
Well, enhanced rock weathering basically takes the natural process where rocks break down over time when exposed to rainwater and CO2, and it puts it on fast forward
Oh.
by grinding the basalt rock into a superfine powder.
Hmm.
Think about surface area. Jake Jordan used a great analogy in the article.
Oh, yeah.
He said it's like dissolving powdered sugar versus a sugar cube. The powder dissolves way, way faster because there's so much more surface for the water, or in this case, the slightly acidic rainwater, to react with.
Okay, powdered sugar versus a sugar cube. Got it. More surface, faster reaction. So the CO2 reacts with this basalt dust. Then what? Where does it go?
Good question. The CO2 reacts with the minerals in the basalt, and it forms something called bicarbonate.
That's how.
This bicarbonate then dissolves into the groundwater.
And just stays there.
Eventually, it flows with the groundwater into rivers and ultimately makes its way to the oceans. And the really key thing here is how long it stays locked up.
How long are we talking?
We're talking over 10,000 years.
Wow. 10,000 years.
That's
That's essentially permanent on human timescales.
exactly. It's
Yeah.
not just temporarily stored, it's chemically transformed and sequestered for a very, very long time.
Okay, that's impressive. And you mentioned the other side of it, the benefit for the farmers. It's not just carbon capture.
Right. That's crucial. As the basalt breaks down or weathers, it doesn't just react with CO2, it also releases vital nutrients locked inside the rock. Things like calcium, magnesium, potassium,
Plant food, basically.
plant food, exactly. So it naturally improves the soil fertility. Healthier soil means healthier crops, and usually significantly better yields. It's a real win-win.
And that feels especially important in a place like India, right? With so many smallholder farmers who are really vulnerable to climate change.
Absolutely. Smallholders farm almost half, 47% of India's agricultural land. And we saw again this year with the monsoon reports, even if the overall rainfall looks okay, the distribution can be erratic, hitting these small farms really hard.
Yeah.
So anything that makes their soil healthier also makes them more resilient to those unpredictable weather patterns. Madi's approach directly addresses that.
The article mentioned a specific farmer in Chhattisgarh. That story really seemed to illustrate the impact.
Oh, definitely. It makes it concrete. This farmer, just farming a couple of acres, saw his rice yield jump by 70%.
70%, that's huge.
Yeah, from about 2,500 kilos to 3,500 kilos. And the key thing Shantanu Agarwal pointed out was that Mati provides and spreads the basalt for free.
At no cost to the farmer.
Zero cost. So for this farmer, that extra income meant he could actually pay off his debts. He just farmed like normal, but with much better results. You can imagine the difference that makes.
That's life-changing stuff. So how does Maddie actually manage the logistics, getting this stuff to the farmers, making sure it works for their specific land?
Well, their model seems pretty well thought out. They focus on these climate-vulnerable regions, often targeting farmers who might be a bit more remote or haven't had access to other, maybe more expensive innovations.
Right.
They analyze the local soil, the crops being grown, and even the specific chemistry of the basalt they're sourcing to ensure it's a good fit. And crucially, they handle the delivery and the spreading.
Taking that burden off the farmer.
Completely. The farmer doesn't need special equipment or anything.
And I remember reading something about pesticide use dropping too, because the soil is healthier.
Yeah, another fascinating outcome. Farmers reported using about 65% less pesticide.
65%.
I know. Agarwal had a neat comparison. He said it's like humans taking vitamins for better immunity. Healthier plants are just naturally more resistant to pests and diseases.
Makes sense. Healthier soil, stronger plants.
And that ties in really nicely with India's national goals, too, like the National Mission for Sustainable Agriculture. Reducing chemical inputs is a big part of that.
So Monty's not just in India, right?
Yeah.
Where else are they operating and what's their scale currently? What are they aiming for?
They're currently active in India, Tanzania, and Zambia. Since starting up in 2022, they've partnered with over 16,000 farmers already.
That's pretty quick growth.
It is. And their goal for the end of this year is 30,000 farmers. But the big vision, the really ambitious one, they're talking about impacting 100 million smallholder farmers by 2045.
Wow. 100 million, that's a massive number.
Yeah.
Are they focusing their efforts within India in particular areas?
Yes, primarily in northern Chhattisgarh, Madhya Pradesh, and Jharkhand areas known to be particularly vulnerable to climate shifts.
Okay.
And they're strategically using India's geology. India has these enormous basalt deposits, especially from the Deccan Traps, ancient volcanic flows.
Right, I've heard of those.
The potential is staggering. The article mentioned that theoretically, just using 1% of those reserves could remove all human-caused CO2 currently in the atmosphere, though obviously that's a theoretical maximum.
Still, the resource is there.
Definitely. And they're being smart about it, piggybacking on existing rock-crushing facilities that already supply the construction industry, so they're not building a whole new industrial footprint just for this.
That helps keep costs down, I imagine. But getting to 100 million farmers, that sounds like a monumental challenge. What are the big hurdles they need to clear?
Oh, there are definitely significant hurdles. Farmer trust is a big one, initially.
Why is that?
Well, as Agarwal put it, you're telling a farmer you're going to put dust on their field to remove some invisible gas, CO2, for buyers who are far away. It can sound dubious.
Yeah, I can see that. How do they overcome it?
Demonstration. They start with trial plots. Farmers see the results on a small scale first, the better yields, the healthier plants, maybe neighbors seeing it too. That builds confidence. Seeing is believing, especially when your livelihood depends on it.
Makes sense. Proof on the ground. What else?
Logistics. Just the sheer physical challenge of moving tons and tons of pulverized rock to potentially millions of small, sometimes remote farms across incredibly diverse regions. It's complex and expensive.
How are they tackling that? You mentioned tech.
Yes, they developed their own AI platform called Matic. It helps manage the whole process, farmer engagement, tracking the BOSS application, verifying the carbon capture, trying to streamline things.
AI for rock dust logistics.
Yeah.
Okay.
But even with tech, the scale requires more. They're using a model they call farmer-entrepreneur partners.
Like a franchise model.
Sort of, yeah.
Yeah.
Empowering local people to become partners, managing the ERW process in their own areas. It leverages local knowledge, trust, networks. It's probably essential to reach that 100 million number.
Okay, let's talk money. You said Madi gives the basalt away free. How do they afford that? The carbon credits, right?
Exactly. They sell the carbon removal achieved as credits on the voluntary carbon market. Companies looking to meet their net zero targets buy these credits.
Who's buying right now?
The article mentioned names like Shopify, Stripe, H&M, and the current price is pretty high, around $300 to $400 per ton of CO2 removed.
That funds the whole operation.
That's the idea. It covers the cost of the basalt, the transport, the spreading, the verification. Their goal is to get that price down significantly, maybe to around $100 a ton in the next 5-7 years, to make it more accessible.
But what's the carbon market like in India specifically? Is it mature enough?
That's one of the challenges. Globally, carbon credit prices can be all over the place, sometimes much lower, maybe $10, $30 a ton in 2024 for some types. India's own domestic market is still quite nascent, still developing.
So volatility, uncertainty.
Yeah, a bit. They really need more Indian companies, especially the big successful ones, the unicorns, to step up and buy these removal credits, not just offsets, as part of their environmental or social responsibility, maybe even addressing their historical emissions. That domestic demand is key.
Seems like government could play a role here too. Are they getting any official support?
They are getting some support at the local level, which is great. District officials, agricultural officers, the local agricultural science centers, Krishi Vigyan Kendras or KVKs, they're collaborating.
And research help.
Yes, partnering with respected institutions like IIT Kanpur for research, data collection, validation, that's vital for credibility.
But what about bigger national level support? Could that make a difference?
Oh, absolutely. Imagine if there were national policies, maybe subsidies to help cover the high cost of transporting basalt, or specific incentives for companies buying these high-quality Indian removal credits.
That could really accelerate things.
Hugely, and it fits so well with India's overall climate goals, like the net zero by 2070 target, and the fact that agriculture is just so central to the economy. A solution that helps farmers and the climate should be a priority.
So what's the holdup?
Well, policy change anywhere takes time. You need lots of proof points demonstrating widespread success and benefit to really convince policymakers to invest significantly or create new frameworks. Inertia is always a factor.
Right. And it's worth remembering, this kind of carbon removal, ERW, it's not a silver bullet, is it? It doesn't replace cutting emissions.
Not at all. Jake Jordan was clear on this. We absolutely have to cut emissions drastically, stop pumping more CO2 out there. But we also need ways to remove the excess that's already there and deal with emissions that are really hard to avoid, like some from agriculture.
So a boat hand situation.
Exactly. Reduce and remove. Especially for a country like India that's developing rapidly but still relies heavily on coal, finding effective removal methods alongside the push for renewables is critical. ERW is one piece of that puzzle.
The article also touched on why ERW might be particularly suited to places like India, maybe more so than, say, the US or Europe. What was the reasoning?
A couple of things. One is soil condition. A lot of agricultural land in the global south has faced soil degradation over the years. These soils are often hungry for the kind of nutrients the salt weathering provides.
So they respond better.
They often see a more dramatic improvement. In contrast, many Western farms are already heavily managed with chemical inputs, so the added benefit from basalt might be less pronounced or harder to measure.
And what about farm size? People sometimes worry if these things scale on small farms.
That's the other point. While Western observers might question scaling on millions of tiny plots, the key difference is the direct economic incentive for the smallholder farmer in India. The yield increase isn't just a nice bonus, it can be a game changer for their income.
So the motivation for adoption is really strong.
Much stronger, potentially, than for a large, highly optimized farm elsewhere just looking at carbon payments. It makes India a really interesting place to pioneer this kind of inclusive climate solution.
So this XPRIZE win,
Mm-hmm.
it feels like a major turning point for Carbon. Looking forward, what are the absolute critical things they need to get right to hit that huge 100 million farmer goal?
The prize money and the profile are definitely a massive springboard. But yeah, critical factors, they absolutely have to maintain scientific rigor. Their partnerships with IIT Kanpur, Yale, Sheffield, that validation is essential for credibility, both with farmers and carbon credit buyers.
Okay, science first.
Then, cracking those big challenges we talked about. The logistics at scale, navigating that volatile carbon market, and ideally, securing more supportive government policies, getting those aligned will be crucial.
And keeping the farmer front and center.
Absolutely. Their whole model seems built on delivering real, tangible value to the farmer first. That trust, that shared benefit, has to remain the core focus. If they can keep proving that value, farmer by farmer, community by community, while sorting out the large-scale logistics and finance, they have a real shot.
It's been fascinating digging into this, so just to quickly recap, Carbon's using enhanced rock weathering, essentially accelerating natural processes with basalt dust to achieve this amazing double benefit.
Right. Permanent carbon removal from the air, locked away for millennia, and improved soil health, leading to better crop yields and less pesticide use for farmers, especially vulnerable smallholders.
We've looked at their really ambitious goals, aiming for 100 million farmers, their clever operational model using local partners and tech, but also the big hurdles.
Yeah, the challenges of trust building, logistics across vast areas, the still developing carbon market in India, and the need for policy support. They're not small challenges.
But I think that aha moment you mentioned earlier really sticks. It's the elegance of it, isn't it?
Really?
A solution that tackles climate change while directly benefiting and empowering the people most affected by it.
Exactly. It's not just an environmental fix. It's got this deep social benefit woven right in.
It really leaves you wondering, doesn't it? Could this specific model or variations of it be replicated effectively elsewhere? Could this scale globally to make a truly significant dent in atmospheric CO2 while supporting small farmers worldwide?
What would it take for other countries with similar agricultural profiles or climate vulnerabilities to adopt something like this? It's definitely food for thought about the future of these kinds of nature-based inclusive climate solutions.